Good afternoon. Good afternoon to everyone that joined. This is Joe Hines. I'm CEO of Voice and Data Networks. I want to thank you folks for attending our webinar today. With us today, we have Patty Page, who does the marketing and organizes these webinars and all the follow-ups. So if there's any questions anyone has, her contact information you probably already have, or she will get it to you. Joel Vincent is coming to us from California, and he's going to give our presentation today, and he's on the line, and we'll hand it over to him in a minute. And there's another Mayru person in the room with us up here in Minneapolis, Kim Strawman from Mayru Networks as well. I just want to take about 1 minute to say thank you for joining us for this webinar. Voice and Data runs continuing education. Our previous webinar was on how to be a subject matter expert on communications products. The one before that was on collaboration and communications products, and the one before that was the SIP case study that we did with one of our clients here in Minnesota. So please keep attending. Lots of valuable information, and I appreciate your attention. So the only thing I'm going to say about before I hand it over is that VDN's mission statement, and you can tell with our webinar series, is to make communications applications return profitability and efficiencies to our customers. So we focus on communications applications, and we make sure that those things return the investment that our clients are looking for. And that's our approach. That's one of the reasons we've chosen and partnered with Mayru Networks. Mayru Networks is a organization that just went public this year, in 2010, and focuses their efforts on wireless. And it is a tremendous product that we're having getting a lot of attention in very large and small organizations. It's a change from the classic wireless, and we find an obligation to explain to our customers what that change is and how it benefits them, because it does benefit our customers. So with that, I'm going to, is there any more housekeeping? I'm going to move it over to Joel Vincent, who's going to take us through what those changes are. Joel, are you with us?
I'm here. Am I controlling the presentation right now?
You are, Joel.
Okay. Great. Thank you. Thank you, Joe. Thank you, Patty. Thanks, everybody, for spending a little time with us today. And what I wanted to do, I'm Joel Vincent, Director of Product Marketing for Mayru Networks. And as Joe mentioned, I'm in California today. But I wanted to spend a little time today to go through a bit about Wi-Fi architecture and technology, and in particular, the advances in technology over the last 10 years. A lot of question and a lot of people are assuming Wi-Fi and Wi-Fi connectivity, and it's out there. What is it about? What's going on? What's the big buzz? I think that enterprises have been addressing it for a while, but I can tell you that the explosion in devices and what's going on in the world of Wi-Fi today, it's taken everybody by surprise. And what we want to be able to do is, can I page down here, is kind of give you a flavor for why we all need to pay attention, and then how can we leverage this and leverage some technology advances to better our business and better our bottom lines. So why pay attention? There's so much is riding on your network, right? So even though you may roll out a massive application across the entire network, it could be voice in particular, you could roll that out and you roll it to every desk, voice over IP. And even though wireless LAN might be a small portion of that entire spend of that IT project, how it performs is always ends up being the most visible thing. If your email is not working, if file is kind of slow coming down over, there's some toleration built into the end user for that. If the voice stops working, or if the mission critical application, something in healthcare stops working, users start yelling. Users get upset. They want to know. They call. That generates phone calls, which anybody who's managing a help desk knows that's what ends up costing you money. That's where the money trail starts. So even though it's a small portion of the overall spend, how it performs is going to be one of the most visible parts of the whole entire network. So wireless, it just has to work, and there have been some, which leads us to some real technology advancements. Some looking at how do we build wireless specifically for an enterprise and not adapt an old style of wireless to new problems that didn't exist before. And then once you have that all under control, when you start talking about returning the return on investment of profitability and efficiencies, you're really talking about moving your thinking and your day-to-day concern away from being tied to specific equipment and devices and how are the devices connecting and what is the RF doing and very low-level kind of techie details, and start spending more and more of your time looking at the services and applications and how do I enhance our business with IT. This is stable over here. I have it under control. I'm using a manageable amount of human resource to keep it under control. How do I now spend more of my brain power looking at the services and applications and how to enhance the overall business? And that's kind of what we're talking about. So the evolution really quickly on wireless LAN, it's worth noting where it all came from. And when you look at the different generations of Wi-Fi and where it's evolved from in the early and mid-90s of just trying to unwire a few devices, and it made it into homes, and this concept of, well, we'll just keep the devices on different channels so homes and maybe some small businesses don't interfere with each other. In 2000, late 90s and 2000, things really started to accelerate with the standardization. And you had the concept of everything kind of being contained in one single access point, firewall, access, all those kind of things at a single access point, and more laptops with the standardization started making it into the enterprise. So you started seeing offices here and there and conference rooms in offices and things like that have some Wi-Fi just for a network of convenience, if you will. Fast forward a little bit further, and you started to see more and more clients coming in, this all being driven into the enterprise by the laptops, by the proliferation. It became standard. Intel built it in, so every laptop came with it, and CIOs wanted to use it. So now you saw more and more this concept of pervasive coverage. We want to go, okay, I want wireless to be covered everywhere, and you started to get into this issue of, well, this technology that was built to cover spotty areas and be a network of convenience is now being asked to do something it wasn't originally designed to do. It wasn't originally designed to cover pervasively everywhere. So the first problem that was solved in 2002 to 2005, around in that range, was, well, my first problem is with all these access points, I need to centralize the management security. I can't go and touch every one of these access points. That's too much of an administrative cost. Okay, so there was an innovation called a controller-based architecture, which allowed you to centralize all that management and push it out to the access points. And that was great, but it left the RF unchanged, principally unchanged from where it was in the 90s. So you had this kind of small business technology being driven into the enterprise. You have the security under control, management under control, and that quickly became table stakes. Controller-based architecture was the way to go for that. Now what do you do with the RF? In 2005, it seemed to be under control. I can tell you now, looking back at the reports, every analyst that told you there was going to be so many Wi-Fi devices connected to your network by 2010 missed on an average by an order of magnitude. So 10x the number of clients that they thought were going to be here today are actually here today. So everything that you thought that network in 2005, 2006 would be able to handle, you have to handle way more than you ever thought. So what fourth generation technology, it moves just from centralization of the management to actually traffic optimizing and looking at assuming that the network is going to be pervasive and coverage is going to be everywhere. How do we then manage the coverage, manage the RF, and actually make it a manageable part of an enterprise network and a critical part of an enterprise network? Be the primary primary method of access? And the answer was really to building it from the ground up, assuming pervasive coverage, start virtualizing. And there's a lot of talk of virtualization out there, server virtualization. What that basically means is create an abstraction layer that allows you to manage things that you know, the applications, the network settings, and things like that, and takes away the physical aspects of the RF, the physical aspects of wireless, RF, number of APs, channel planning, all these kind of very complicated things that you had to do in the microcell, what we call microcell architecture, and allow clients to just look at one contiguous, pervasive coverage of wireless in what we call a virtual cell. Once that cell is virtualized and the system's taking care of all the complicated RF issues that are going on, you can get back to what we said before. When you want to get to profitability and efficiencies, you can get back to managing the network with your network architects and letting the system deal with complications within the RF. And I'll talk more about virtual cell and things like that in a little bit. Trying to switch slides here. So simplifying, making that shift from the third generation to the fourth generation technologies. When you looked at the legacy, well, I'll just bundle all the rest of that into legacy and where we are today with fourth generation. You had that microcell deployment, and a lot of people like to use the analogy. There's a very similar analogy in the wired world between hubs and switches. What you had was a hub for a low number of wired devices at the time. It was fine. When the wired devices became pretty pervasive, you started to run into crowding and traffic and predictability and complicated ways of solving things, and things became very complex. The innovation that happened was a switch. It took the shared hub and arbitrated the shared medium so that each port on a device got its own policies. It didn't see other devices. The quality of service was controllable on a per port basis as opposed to a per hub basis. And that's essentially what you start to be able to do once you virtualize the technology. So the system takes over what's going on. You end up, instead of channel planning and things like that, the system will take over the shared medium, the air, and what it will do is arbitrate that shared medium so that every device has fair access, has its own policies, and there's several ways to do it. I'll go into how we implemented it, but every device has its fair access, has its own policies, sees only its own access point, things like that. And you've essentially created an analogous situation with the air. In a wired world, you had hubs that were shared across the backplane, basically, of that box. You moved it to switches so that the switch then arbitrated that shared backplane so that every device had its own port and didn't see everything else, and that solved a lot of traffic and collisions and things like that. What we're talking about in Wi-Fi is going through the same thing. You have a shared medium, air, management centralized, security centralized, those are table stakes. But what we're seeing now with just a proliferation of devices, there's a lot of problems with the air being so shared among all the devices. So what we end up doing is doing the hub to switch, making the shared, arbitrating the shared medium, taking over control of what's going on over the air, arbitrating that so that you have a switch-like effect. You don't have as many collisions, you have better quality of service, you have a more predictable network. And since the network is taking care of the RF issues, the co-channel interference, and many access points on the same channel, all those sorts of things, it becomes a much, much simpler problem. You don't need to be the RF expert. You don't have to have a staff of RF architects, which are very rare. The good ones are very good, but they're hard to find. So you'll either have to retrain your staff or find some expensive resources just to manage your wireless network. In the case of a virtualized network, you create this abstraction layer, and you're back to managing network devices and security policies and things that your CCIEs, your CNAs, or whoever it may be, are used to dealing with, and the system takes care of the RF. So we're kind of talking about that when we talk about moving from the legacy microcell architectures to more of a virtualized situation. So why do it in your business? There's three primary reasons for virtualization, and it's true across virtualization of servers, virtualization of whatever it is. It's agility for your business. You're able to, and this is particularly important for wireless, and I'll explain why, but what I mean by agility is business agility. You can have the quality of service, you can have the applications deployed where you want, when you want, and not have to worry about will the network be able to handle it, and also be able to have a right size for your network. You don't want to build for the worst case scenario everywhere in your network just in case that's what happens. Because once you introduce mobility into your network, you don't know where the crowd is going to be. You don't know where the application is going to be used most, because the point of mobility is you should be able to use the application with a good quality of service and efficiently and effectively no matter where you are. So when you're actually virtualized and you detach the reliance, the relationship between the number of devices and the performance you're going to get or anything like that, and it's just you want to make it wherever you are, you get the same performance, you then get that agility. You can deploy an application, and the people who use that application can be anywhere, and you don't have to worry about it. And you also don't have to overbuild your network to make sure, oh, worst case scenario has to be handled everywhere. That's the only way to do mobility. That's not the right way to do mobility. Predictability goes back to the same thing. You have the performance anywhere you need it, on demand, elastic, capabilities, quality of service dynamically assigned. And then simplicity is you don't need to be the RF expert in every situation. You can cover your campus pervasively, virtualize it, use the virtual cells, and we'll talk about how to add capacity with virtualization and things like that. You know that you have a switch-like performance where you're giving every client that's on your network the quality of service and performance that it requires individually, and then you don't have to deal with all the RF implementations, and it keeps it very simple for you in terms of operational expense. Patty, don't move your mouse, because when you move it, I lose control. Okay, there we go. So I think we're going to launch into a quick poll. And we'll give you a couple minutes to chew on that one.
Folks, if you go ahead and use the GoToWebinar control panel, you'll be able to access the poll question. We'll give you folks another about 15 seconds. We'll wait so everybody has an opportunity.
Okay. Are we ready, Pat? Patty?
Yes, go ahead, Joel. Thank you.
All right. Oops. All right. So to talk a little bit, to continue on now, talk a little bit about what I introduced there in the overview. We talked about agility, the predictability, and the performance. Agility. Let me get a bit into a little more specific on what is wireless LAN virtualization. What is this shift of why do we care, and what is this shift of microcell to virtualized and third to fourth generation and things like that. So technologically speaking, wireless LANs today, microcell, the legacy wireless LANs, microcell or just unvirtualized, if you want to call it that, you have an access point, a shared medium. You're going to have your laptops certified. The standardization is there, and I'm not showing the back-end control and security and management and security because those basic functions are table stakes. It's going to be vendor to vendor, 6 to 1, half a dozen to the other when it comes to that. But you're looking at the shared medium, the laptops, the handheld devices, whatever it is, and this is what everybody has been familiar with in the past. What we're talking about going forward is sort of, if we wanted to do it visually, put a little space in between those guys and start to create an environment for each individual client. What we call it is a virtual port. So just like a switch port from a hub to a switch port, we create a virtual port over the air. And now we have each client in their perceiving, what the abstraction we're creating for them is they perceive their own port. They have their own access point. And that access point, we can then administrate that access point. We can give it the quality of service that it needs, the security parameters that it needs. You can have a guest person right next to the CEO, and they will not even, they being their laptops or their devices, won't even see each other. Where the network is controlling what they see, where they go, how they do it, who has priority over what. And then further, we can tell, we take over control of the communication of this client. So we can tell when they initiate a voice call. Let's say they initiate a voice call in the middle of all this traffic, and then we can kind of tell the other clients in their area, all right, without them knowing, don't transmit right now. There's a voice packet coming, and we kind of clear the air and give you bidirectional quality of service for that port, and everything else you need to do. And this is all done automatically by the system. So as far as the client knows, they're in their own virtual world there, and it's got all its own security policies, and as they walk around, all of that stuff goes with them. So they have their virtual port. To go a little bit further with that, to address the virtualization, addressing the mobility portion, is behind these virtual ports, the access points are on the same channel, and they see each other, and they're coordinating between each other. So when client A is communicating with access point A will talk to access point B and say, this guy's going to make a voice call. You make sure everyone in your cell doesn't interfere with my guy making a voice call. So we'll go ahead and let that voice call go through, and you'll have a nice high. And we consistently have very high mean opinion scores or very high voice quality in our network for this reason. We're in control of who's speaking when, and we control that over the entire network. So we call it intercell coordination, but it's just an algorithm within the virtualization. So these access points are all on the same channel. And then we say, okay, let's all coordinate together and make sure that everything moves in a nice, orderly fashion. Not ironically, we call it air traffic control technology. The analogy I like to use is when you're controlling, this is just an example, quality of service for voice, for example. If it's very much like an air traffic control system across the United States. In a traditional or legacy, whatever you want to call it, wireless LAN, where the client is deciding when to transmit and back off and all those sorts of things, that would be akin to all the airplanes in the air trying to decide amongst themselves when they get to land at an airport. What ends up happening is everybody, is so scared to land that they never actually land at an airport. So what do? You put in the air traffic control system, and in a nice, orderly fashion, we actually move millions and millions of people every day all across the country in airplanes, and and don't have collisions all day long. So we effectively do the same thing with our air traffic control technology, which is a key technology in all of this virtualization that I'm talking about. So now you have your virtual environment within your virtual port, and then we put those on top of a virtual cell so that you can then move anywhere you want, and we'll pass you from access point to access point, very much like a cellular network. When you're driving down the highway in a cellular network, your phone doesn't decide what cell tower it's going to talk to. The system is going to decide this cell tower has capacity, you're close to it, it's going to give you the best service, you go work over there. That's exactly what we're doing. It's simplicity, and yet there's a lot behind it. I always tell people there's an inverse relationship between how simple something is and the amount of engineering that goes into it. If you think that a command line interface is more powerful, or if you think about a computer with a command line interface versus the Mac OS, command line interface, I can tell you, is much easier to engineer than the Mac OS. But the Mac OS comes off much simpler, and consumers can actually use it. So, same idea. The concepts are very simple, but it takes very advanced algorithms, and it unlocks a whole series of powerful things that you can do with your network. So as you move around, the APs move around, and the clients are none the wiser. They just see one AP everywhere they go. So the virtual port, just to summarize that kind of diatribe there, it gives you more control over what's going on. The clients aren't in control of the communication. We are. The network is. Device isolation, security policies. People can be standing next to each other. You can be in a retail store and have the customer standing right next to the POS system. The POS is going to have a higher priority. It's going to be way more secure. The guest, i.e. the customer, is going to have great service, but they'll never be contending with the POS system, the mobile POS system that you have the employee using right next to them. Per device multimedia or multi-access to whatever application. And the benefits are, once you arbitrate the air, and if you're deploying tens or hundreds of APs and the system is taking care of what's going on over there, there's all sorts of ways that you can increase the density. And you can do it dynamically, and you can do it in a way that won't interfere with other parts of the network, and I'll talk about that in a minute. It gives you a predictable, stable environment, and it allows you to customize the experience to each individual client that's on the network if you wanted to. Typically, you just put policies in and base it on radius and things like that, but you could actually go down and customize for every single application, every single person on the network if you wanted to get that down, get that detail. The virtual cell itself, it's every device's standard AP moves with it through the network. So you have your standard AP, it moves with you, and that functionality is the virtual cell. It again gives you that network control, who moves where, and control in this case is if there is a crowded area and there's one AP that it basically has too many clients attached to it, but there's another AP that's pretty close that could service some of those people better because it can also see those clients. The system will load balance between the APs on the same channel and allow kind of a collaborative. It gives you the power at the point of need, effectively. And then the seamless handoff allows you to roam. So it gives you extremely rapid deployment with the optimized coverage. If you're using channels for coverage and you're not worrying about how many APs do I have to alternate channels to avoid interference, we literally have a rule of thumb, if you will. If you're going into a totally greenfield situation, you could literally go, I'm going to put an AP every 6 ceiling tiles. And then deploy it that way, walk around, or every 10 ceiling tiles if they're 6 by 6, let's say 60 feet. Walk around, make sure that there's no shadows. You're installing them like light bulbs, make sure there's no shadows. All right, everything's good, turn it on, and you're off and running. It gives you extremely go from time to planning, or planning to service time is very, very short. We're able to, instance after instance with our system, we've had retail stores be able to deploy 100 stores in 3 months. On Twitter, I picked up a tweet the other day that said, just deployed 200 Mirror Networks APs in a day. So we virtualizing, taking away from the implementers what they have to do with the RF and really simplifying the planning to, this is a clean channel, this is the one we're going to use, let's start putting up the light bulbs. It just changes what you have to do operationally with the network, and it makes you much, much more efficient. So comparing that to the legacy modes, the microcell deployments where you're alternating channels and you're doing a static RF plan or even a dynamic RF plan, but the fundamental principle is we want the APs on different channels so they don't collide with each other. what ends up happening is and the clients remain in control of the communication. This is a throughput graph of someone walking across 5 APs in 600 feet. And what you see is the client in blue is attached is the microcell client going across APs on different channels. And the dips are when the client has to start making a decision. The client is under AP2, and it's actually trying to make a decision between AP1 and AP3. It never actually attaches to AP2. Makes that decision, and boop, their throughput bounces back up. And it'll do it again going further down. Whereas versus with the virtualized system, we're going to pass you from AP to AP to make sure you get the best. Once your signal starts dipping, you'll get a much more consistent experience. And I can take away the word throughput, and I can put experience, voice quality, whatever you want to put in there. The point is, when the clients go into this mode of making a decision, you can have, some people have very strict security policies. When they change access points, it might have to change, re-authenticate security-wise and do a little bit more and make the handoff longer and things like that. The point is, when the client is in control of what access point they're talking to, there's a lot of things that can confuse the client, and it makes that experience inconsistent. Whether the experience is throughput, voice quality, whatever you want to put, you'll see a similar thing. The technical details are sticky client, whatever you want to say. If the client is in control of the communication and you don't take over control from that client, you're going to get an inconsistent experience from that client. Simplicity, this is actually a really short section because it's really easy to explain. 802.11n, the latest and greatest, with its multiple in, multiple out antenna scheme, actually using reflections and using interfering objects as a way to recreate signal. What was hard with microcell before was you had to channel plan for these assumed to be almost circular patterns of coverage. Throw in the 802.11n into the mix, and you end up with a pattern coverage that kind of looks like this. What you're looking at is a graph of the dark areas being strong signals, the light areas being weak signals, and the goal is to make the whole floor look dark. So if you're alternating channels, you'll have a pattern like this coming out of every AP on different channels. It causes a couple things. It's going to be very hard. You can't predict where the signal is going to bounce and where you're going to be able to recreate signal. So you'll have interference in places where you had no idea you'd have interference, and you'll have coverage gaps in places where you thought you had coverage. That's just the nature of MIMO and the way it goes. And you're going to really have to concern yourself with this and figure out how to overcome this if you stay attached to, I want to control the RF and control power levels. And there are some very good RF architects that might be able to help you with this, but once they put that plan in, you change the environment, and then you're back in trouble again. A good example is, how do you do what's called a static RF plan? I'm going to put the APs here, here, and here, and here, and then I'm going to put this on this channel, that on that channel, whatever it is, in a warehouse. On Monday, a warehouse for a retailer, Monday the warehouse is full. On Friday, the warehouse is empty. Those are two completely different RF environments. How the system adjusts for that, adjusts in interference, avoids interference, et cetera, it's hard to say. When the system is assuming interference and coordinating between APs, and actually when the APs see each other, it's actually better for the system. It really simplifies what's going on there. You remove yourself from managing these sorts of things and allow yourself to concern yourself with how well is the application performing, how happy are the people, and let the system take care of the RF. So this simplification that we perform, and I'm going to try to go through the rest of this pretty quickly because I'm actually running out of time, but we prove it time and time again. And at Meru, with our customers deployed, and we have video case studies on our websites and things like that our customers talking. We literally have a major metro school district, 1.5 employees. The dark little dark things you have there, Empire State Building, just for a point of reference, 3 million square feet of offices. Major metro area school district, 1.5 full-time employees managing 45 million square feet. That's 15 Empire State Buildings worth of RF coverage. a university in the southern U.S. Scaled up from 100,000 square feet of coverage to 8.25 million, or 2.5 Empire State Buildings, square feet of wireless coverage, only added one full-time employee. And, you know, a big box retailer, I mentioned it, one full-time employee managing 100 stores. And they're scaling up from there, and they haven't added employees. So the point is, if once you pull out the need to have these experts, and the only people who can deal with the network are RF experts, you pull yourself out of that situation, and you allow, you know, network people to take care of your wireless network, and maybe a small amount of RF people to do some of the trickier things. You get to a much more efficient, scalable model, and you can actually start to use your wireless network as the primary network of access and not worry about it swamping your IT resources. So right now, let's launch into another quick poll. I'll let Patty take over. So how many people do you have dedicated to managing your wireless LAN? And I think this is an important one because I don't think people think about dedicating people to their wireless LAN. So we kind of threw this in there to give you an idea. When you think about it, how many do you actually have? And if it's not that many, how many are you going to be able to add when you make that decision on what network you want to buy, or what generation of network you want to buy?
Folks, we'll wait another 15 seconds to let everybody give everybody the opportunity to answer the poll by using the GoToWebinar control panel. Folks, just wanted to give you the results of the two polls that we had today for what's the key difference between third and fourth generation. 88% of you actually answered, the first answer was 4G incorporates virtual cells. B was 3G acts like a hub versus 4G acts like a switch. C was 4G assumes pervasive wireless coverage over the campus. And D, 6G is reserved for Ozzy Osbourne, not Justin Bieber. 88% of you, let's say 13% of you answered 4G assumes pervasive wireless coverage over the campus. And 88% of you were correct in answering A, B, and C are correct. And for our second poll, how many people do you have dedicated to managing your LAN? 33% of you answered 0.25. 17 of you at 0.5, 33 answered 1 full-time, and 17 answered over 3 full-time employees. Thank you for answering both our polls. Go ahead, Joel.
All right. Thanks very much. Okay, so the rest of this I'll move through a little bit more succinctly. I probably have too many slides on density, but starting off, what is dense? There's a pure number of clients, but really density, it goes back to what we were talking about before. Density means different things to different people. There's a pure number of clients, but really what the application you're running on that client and the quality of service that you need for that application, let's say voice. If you had 250 data users in a single area, that's a challenging scenario. The same amount of challenging if you add voice to that situation. If you have 50 voice calls in a single area, that's a challenging situation. So density means different things to different people, and the concept of virtualization across any computing area is this idea of elastic power and elastic computing capability. And the point of virtualization in the wireless LAN is to give you that dynamic quality of service that's coordinated across the whole network because you're arbitrating a shared medium. And how do I allow density to not only provide quality of service and density at the same time, but when that density starts to move, or when you have a really dense area next to a lightly populated area, how do I make sure everybody continues to get fair access? How do I make sure that again, the mobile POS system, I brought that up earlier, in a store is getting fair access to the network, even though there's a whole lot of people in the store using Wi-Fi to look up products or whatever it might be. In this case, and I'll flip through this kind of quickly, the explosion of devices that I talked about, the exceeding all expectations by a factor of 10, this is not news to anybody. It comes from, we were looking at laptops in 2005 and prior to that. And then we had laptops and smartphones that hit a tipping point. Now all of a sudden we're looking at laptops, smartphones, and tablets. And I almost want to put iPads in a different class as tablets, but you're going to have an arms race in tablets too, and people using those for different things. Even saw an article this morning where restaurants using them now with Wi-Fi, obviously because they don't have Ethernet, to replace menus and start cutting back on waitresses. Things. So you just have an explosion of devices and uses that we didn't predict before, but now that it's there, it makes a lot of sense, and we need to have the ability to support all of those things. The numbers can add up. I'll go through this one quickly. 250 people at a conference area or a lecture hall is the obvious one. You start exploding those devices, you quickly have a lot of devices in a small area. This is evidenced by almost every conference you read about now, even Mobile World Congress that's going on right now. There's already talk of the Wi-Fi failing on that, and it seems to be a popular topic right now. Venues are places that we're starting to get much more business from, because when an event comes to a venue, it's not the Wi-Fi at the Mobile World Congress was terrible. It's the Wi-Fi at the stadium, at the conference center was terrible. In San Francisco, there's Moscone where the iPhone 4 debacle happened. It wasn't Apple's Wi-Fi is terrible. It's the Wi-Fi at the Moscone is terrible. So, the venues themselves are the early experiencers of this. But with the proliferation of devices, that bulge of devices is gonna start making it into enterprises. And IT departments are going to have to figure out how to support density in areas where they never thought it was possible before. So at Meru, we created, just as a demo network, just to show what you can do, we call it a WLAN 500. And density can come from many sources, but we put in 500 clients and 500 square feet with 45 videos and 100 calls running on a virtualized wireless LAN. We were able to support the density and provide service levels. It wasn't a trade-off of okay, well, I'm going to add APs and shrink cells and do those kind of things. We provide the density and service levels to everybody that's on the network. The important point of this is how do we do that, and how do you do it pervasively? Well, in a microcell network, the design principle is as density increases, there is this relationship because of the alternating of channels. You want to try to keep so many clients per access point, so you're going to want to shrink the cell size and reduce the power, and or go through some complex complications that tell you link budgeting and things like that, so that you actually reuse spectrum efficiently, and it really forces you into some complicated situations. So the way to handle density, reduce power, add APs. With the client in control of the situation, if you start reducing power and adding APs, a client's going to see more APs, get confused more often, and have worse performance. We talked about all the APs being on the same channel in this virtual cell. To add capacity of virtual cell, okay, we'll cover this whole area with one channel. This area is usually more dense. We'll put a couple more channels in the same area. And it won't cause interference in the rest of the network because we're not using the channels for coverage, we're using the channels for capacity and redundancy. So I have a really dense area in this. I'm just going to layer another channel over here on the right-hand side of this. I'll put another channel. So I'll have 3 channels of capacity covering this area where I know it's dense, and a couple over here where it's less dense, and it just needs some redundant channels for whatever reason. And at Mayra, we have a range of APs that allow you to do that, so you don't have to use, the top-end AP everywhere. In the same way that you design a wide area network, you have the main pipe, your OC48 from the main site, but you don't just leave that out there by itself. You'll back it up with an OC12 or some other smaller pipe. It's the same idea here. We have utility APs, and we have the high-end APs to allow you to architect the network for your situation and be able to channel layer redundantly where you need to. So in that example with the WLAN 500, this is sort of an architectural picture. What we did is we stacked the APs, we stacked a bunch of channels on top of each other in that 500 square foot area. So they had about 6 APs that could cover that area. But the important point here is this was at our corporate headquarters. So we had the rest of the corporate network was still there. So even though we were using all these channels to do that density in that 500 square foot area downstairs from my office, it didn't kill my wireless network. I was still able to work. So I'm able to design, scale for density where I need it. And in the surrounding areas, instead of being trounced because all that traffic is going on down in the density lab and in the density area of the headquarters, we can still do a production network on 2 of the channels and get fair access for people in finance and marketing and sales and everybody who's not an engineer. So you can scale for density where you need it and yet deliver service levels everywhere dynamically. Service assurance is the last aspect. This is where predictability comes in. So really quickly, virtualization gives you a unique visibility when you start talking about managing the network. How does 1.5 people manage 45 million square feet? Well, when you have the APs out there, the basic architecture says a lot of them are on the same channel. All right, if they're on the same channel, let's use them to test each other. We create little virtual clients. We do regular polls, and we inject traffic into the network, and we start to paint a picture for ourselves. What does the client experience look like? And simulate applications and their trends. So then we can actually tell before someone walks into that corner of the building that there's going to be a problem in that corner of the building. So I can walk in the morning, get an executive level report, a health report, kind of a dashboard or a report card that says, oh, okay, I see it. There's a red part of my, there's red on this graph. I don't even need to read to you what it says there. There's red on this graph. I'll drill down, figure out what my virtual client had experienced. Oh, it had a DHCP response problem. Okay, hey, I'll fix that. So what ends up happening, I see it, I drill down on it, and I can go and address it before the people who, some people may wander into that area and start experiencing a bad network. We can predict that and fix it before it happens. The second aspect of managing this is, what happens with interference and things that are out of your control, that, a rogue access point or interference from the common one you always hear is a microwave oven. Well, now that the system is taking care of the interference, the co-channel interference, and the taking control of what the clients are doing and all the interference that's under its control, you can focus on specialized wireless services, and we have the product line allow you to do that. That lets you, let the system worry about the AP and the RF management, and you can do things like start getting down to the detail of what's going on in the spectrum. Why is this area, have some strange interference that we don't understand? You can identify, fingerprint the interference, and do what you have to design around it on an ongoing basis. So, and then we have it built into our EasyRF and our what we call our service assurance management platform, the applications that allow you to look across the spectrum and fix what you need to fix. You can identify and locate rogue access points, mitigate them, and then go take them down, depending on your situation. So when you're not constantly in the battle of trying to figure out, clients are coming in like crazy, I need to support this and that application. How am I going to re-architect? How am I going to add APs? Where am I going to add APs and reduce cell size and do link budgeting? When you get yourself out of that and you start to look at services, applications, and stop looking at devices and equipment. And that's what we're driving at with virtualization. So yeah, I just threw this up here. Microwave interference is screened from our spectrum, proactive spectrum analyzer, we call it. And it's just, there's microwave. The common example is, oh, what if somebody turns on a microwave? Well, you probably know where the microwave is. All you need to know is, okay, in that area, I'm not going to. It's hard to read here, but channel 11 is going to be crowded by the microwave. Put the APs on channel 6 and call it a day. Let them turn on the microwave all day long. It won't bother your network. So it's not really unpredictable interference. It's predictable because you know where it's going to be. So you just plan around it. In the microcell world, if that microwave was taking up channel 11 like this, they would say, oh, let's move the AP off of channel 11 when that microwave comes on and move it on channel 6. Well, now you're on the same channel as another AP in your network, and you've moved the interference from the microwave to two APs on the same channel, and you've caused a different problem. So the point of virtualization is to use these services as planning tools, but once the network is in, it can dynamically take care of what it needs to take care of. So really quickly, getting there from here, how we set up our boxes. Like I said, the controller-based architecture is where we base it. So we have a controller, and the services from our service assurance platform are delivered centrally at a data center, or you can. This is a general deployment example. There are different, depending on your architecture, you can customize where you put the controllers and things like that. But the controllers manage APs anywhere in your campus. In this case, we had a headquarters. We're showing headquarters and a warehouse for a retailer. Then you add the applications that you want to use. In this case, if it's a retailer, they're going to want wireless intrusion protection. They're going to want PCI. They're going to want the service assurance manager. All that gets added to the service assurance platform. And then once you add it to the service assurance platform, it's a service that's available anywhere in the virtualized wireless LAN. The virtualized wireless LAN includes what's directly connected to headquarters, as well as anything that you deploy where there's a major network's access point. There are several software modules that we have available, with more coming, and like I said, it's just a matter of turning them on the service assurance, the service supply and service assurance manager platform. So you turn on, you have the network manager is by default going to be there. You can turn on SAM if you want the spectrum manager, and you have the spectrum analyzers out there. You can turn that on. Compliance manager for retailers. It's just a matter of flipping a switch to get it going. And then the product line itself, from controllers through and access points, it's really for remote branch office all the way through your headquarters deployment. So we have the whole range of access points to create your virtualized wireless LAN. So with that, I'll turn it back over to Patty. I know that this was kind of a summary overview, and but what I wanted to point everyone to, and I think I'll let Patty talk about it a little bit, but I do want to mention that the presenter, we do have lots of videos, and VDN will has a landing page for you. But these are presented by our CTO, and the founder of the company, and the guy who came up with our methodology of creating virtualized wireless LANs. And the videos that VDN has will present to you a lot of the concepts. I was talking very conceptual. I know it sounded very high level, but we didn't have a lot of time. There are several videos, and I think these are the relevant ones. VDN is giving you the relevant ones for kind of the concepts that I presented today. Patty?
Yes, thank you, Joel. As Joel mentioned, we will be emailing all of you after the webinar, hopefully tomorrow, these additional resources, and there will be videos available to all of you. And again, they're very short videos, 3 to maybe 10 minutes each, actually. And those will come your way, again, probably Friday or Monday. If any of you have any questions at this time, please use the GoToWebinar control panel to raise your hand, and we can unmute you to ask your question. Okay, folks, well, thank you for joining us today, and if you do have any questions, please feel free to contact your VDN account executive, or if you do not yet have a dedicated account executive, please call me, Patty Page, and we'll show you our contact information here, and we'll get you in touch with one of our account executives. Again, thank you so much for joining us. Thank you, Joel. And please look forward to our emails coming in the next couple of days.